So our next talk is by Clive Neal on how is the Artemis Base Camp sustainable?
So I want to talk a little bit about the Artemis Base Camp and the Artemis rollout that we have that was just came out from NASA, and I put the URL at the top there. Of course, it's one of those that is easily memorized, but it'll be on the on the slides when they go up on the website. But one thing to look at here is the idea that we have this sustainable architecture, and I've highlighted a piece from this document. In placing and building the infrastructure, systems and robotic missions that can enable a sustained lunar surface presence. And I've been trying to understand how that is going to be sustained, and that's why the questions I've been asking throughout today, especially this morning, I thought were pretty important to try and get a handle on this, because it's important for science endeavors as well as many other things. And Jake and Ben and Sarah gave presentations about the NASA perspective on this early today, about how the science impact of Artemis is going to be rather impressive. However, if we look at this document, there's no date given for the establishment of our base camp, and the administrator was quite pointed about having a date to be able to drive his budget as best as he can. But there's very few details on how sustainability of lunar exploration and development will actually occur. There is no definition, so there's no real pathway for longevity. But if we look at how human lunar exploration can be sustained, and I've looked a lot at Apollo, and I've looked a lot at the failed other attempts to go back to the moon, and we need long-term political support and public funding, long-term public support and international buy-in and partnerships, cooperation, not competition, because Apollo barely lasted 3 years before it was cut due to the fact that it was done in a spirit of competition. And once the competition had been sorted, then there was no reason to keep going. So, and I think maybe the most important thing is that this has to show that the Artemis has benefits back here on Earth. And I think this is the most important thing to focus on here, because the benefits that can be demonstrated to come back to this planet will facilitate government funding and public support and international partnerships and cooperation. So if we take a look at the return on the government investment that's necessary, there are a number of tangible things we can point at that actually happened during Apollo, and that was the renaissance in STEM education. Jobs, expansion of old and development of new companies and industries, technological advances, medical breakthroughs, and other opportunities that are heretofore sort of thought of, but there are others that haven't been thought of yet that inquiring minds may want to know. So I think that there is important opportunity here, and these nuggets of hope, as I've called them, are sort of scattered within this document. And I just want to point out a few here, because yes, on page 9, it does say we will develop new technologies, going to advance industry and discover new resources that will help grow the economy. So we have a commercial on-ramp in defining new technology areas now and fostering their development. And it was very pointed that Rachel Klima gave a talk about the Lunar Surface Innovation Initiative and through STMD, and the consortium that's being run through APL. This is a great start to showing a return on investment. And some of these technologies could be for cold tech, getting into the PSRs. We tend to gloss over the fact that these are some of the coldest places in the solar system. And so technology needs to develop to be able to actually utilize any materials that are in there. Cryogenic storage and transportation is another issue. I called it the hydrogen problem because hydrogen boils off at very low temperatures, and any technological advances here can have important implications for hydrogen fuel cells and the hydrogen economy back down on this planet. And then engineering landing sites and high traffic operational sites, i.e. dust mitigation, and then robustness of systems. When we ran the Lunar ISRU workshop in last year, we heard loud and clear from the mining industry is that mining is hard on systems, and trying to maintain them even on Earth is difficult. So robustness of systems then becomes essential if we're actually going to do any large-scale movement of regolith, for example, or even thermal mining, because I still think you're going to have to take off that insulating layer somehow at a regular basis of regolith once it's been desiccated. So other nuggets of hope is that just because we're going to Mars doesn't mean to say we're going to abandon the moon. Good to hear the administrator talk about that. It's Moon and Mars for once, and we can actually go out into the solar system together. And it talks about CLIPS being important here. But I put up the CLIPS companies. But what is the evolution path for CLIPS, and how is this entwined with establishing and evolving the Artemis base camp? Because if you're not growing and evolving, you're basically dying. So we need to think about this now and put those steps in place to actually grow this, because it will become important for science development. It will become important for sustained human presence on the moon, and it will become important for developing the economy that will actually promote sustainability. And then finally, talking about the ISRU will enable the production of fuel, water, and oxygen from local materials. And again, it says in the document that this will enable sustainable surface operations with decreasing supply needs from Earth. So we have another commercial on-ramp here, and we can actually estimate what the demand would be for life support consumables. You can see here that oxygen and water, both in kilograms, and you can see that this may not be the driver in terms of getting commercial involvement. It may not be viable for commercial companies to be involved in supplying these sorts of needs. But again, the Artemis Base Camp is slated to have a transportation system. The human lunar landers are refuelable, at least the descent stages are going to be refuelable. So we have an opportunity here to start expanding the propellant side of the demand. And again, we actually now develop another commercial on-ramp. But critical in this is reusable engine development. And that type of engine, whether it's methane or hydrogen being mixed with oxygen, could actually drive the demand for the resources. And you can see in the graph on the table on the right, you've got manufacturable on the moon. Yes, you can manufacture methane, but you need a carbon source to be able to do that. Whereas we know that there's water on the moon, and that this is certainly a potential fuel source, because water, as we look at our solar system, and the more that we learn, is potentially the oil of our solar system as humans move out ever beyond the Earth-Moon system. So, just to wrap things up, we need to understand, and we've heard this a few times, if resources are reserved. But I want to emphasize the point here is that over in this diagram on the right, economic is part of definition of reserves. So we need to make sure that if we're going to get reserves, so understand if there are reserves there, what is the economic cost of extracting them? So a resource prospecting campaign is certainly essential and needed. And Viper, I think this is one of the most critical missions NASA has ever done, because it represents a good start to a prospecting campaign. Very encouraged by the talks we've heard about Viper today. And I think this deserves full community support, because if we look at the types of data that we're going to get out of Viper, they are going to inform science, exploration, as well as commercial markets. And I think that it's important that we don't stovepipe this as a science mission. It is a space exploration mission that is going to inform science, exploration, and commercial entities to derive business plans. So Final slide. We need to show the return on the government or taxpayer investment. And we can do that through, it's the best way to make Artemis Base Camp sustainable. Immediate need is to prove lunar resources are reserves. And we need to sort of establish markets to close that potential business plan. So how much is NASA and other space agencies willing to pay for those consumables? And then future growth and evolution of the initial base camp will be critical, I think, for sustainability, because it will increase demand and interest as we continue to move forward. So this evolution plan becomes very important for science, exploration, and a sustainable space program through a creation of jobs. Thank you very much.
Thank you. So we have a few questions in the chat. The first is from Mark Siltola. Why would the moon hopper need to be controlled by the Artemis base? Why not from the Gateway or even Earth?
It's could be controlled from anywhere. The point is that it's a intra-lunar transportation facility that is reusable and can be refueled by, it puts a demand on the need for local resources to able to do that.
And then another question by Annabelle Peltzer. Because the moon has significantly less gravity compared to Earth, is generating artificial gravity for an astronaut on longer missions a possibility, or is something like that at all in discussion? How will we prevent bone loss? Great question. We know a lot about microgravity and how the skeleton dissolves, and we know 1G, the skeleton tends to stand up to it, but we don't have the database to look at what happens to the gravity at 1.6G. Is that enough to prevent bone loss? We don't know. But this is something that I think is critical to have a sustained, maybe even permanent human presence on the moon to understand this, especially if we're going to get humans to and from Mars and don't kill them in the process. All right, so that's all the time we have for questions now. If you have more questions for Clive, you can ask them during the discussion. And I believe it's over to Christina Gibbs now.